Good morning, good afternoon, and good evening. Welcome to Chapter 2. Chapter 2 is all about chemistry. Hopefully you had chemistry in high school. We're going to go over and review a lot of the stuff that you hopefully learned a few years ago. Life first evolved in water. Because of that, all living things depend on water. Life depends on water. If there is no water, there is no life. All of the reactions, something that we need to talk about, and that is your body is made of cells. All of those cells have water in them. You know that your body is roughly about 75% water. Every cell that you have is just a miniature chemical factory. If it's a miniature chemical factory, that means that it is constantly doing chemical reactions. Chemical reactions to make products that your body needs, chemical reactions to break down things that you take in, food and whatnot. Because every cell is a miniature chemical factory, it means it's doing hundreds or thousands of chemical reactions. So inside all of your cells is mostly water. And because inside all your cells is mostly water, it means that if you don't have any water, then those chemical reactions can't take place. And if those chemical reactions can't take place, then life can't take place. Chemical reactions require water. Life requires chemical actions. Therefore, life requires water. As we said, this chapter is all about chemistry. Matter is what the universe is made of. Matter is anything that occupies space and has mass. Those two properties are inseparable. If it occupies space, it has mass. And if it has mass, it occupies space. They have to go together. Matter is made of elements. Matter is stuff. The elements are, or rather an element. An element is anything that can't be broken down into a simpler form by ordinary chemical means. You know some elements. Oxygen, carbon, hydrogen, gold, silver, platinum, copper. Those are all elements. You can theoretically have a brick of solid gold where every single atom in that brick is gold. You could theoretically have a brick of solid iron where every single atom in that brick is an iron atom. Could you have a solid brick of water atoms? And the answer is no, because water is not an element. I don't care what the last airbender says. Water is not an element. Water is a compound. A compound is something that's made of two or more elements. There are about 92 naturally occurring elements, of which we named about a half dozen. And there are about 25 that are essential to life. Pretty much all the ones I named, life needs at least a little bit. As I said just a minute ago, water is a compound. A compound is something that is made of two or more elements. Water is a great example. You know the formula for water. Everybody knows the formula for water. H2O. H2O means two hydrogen atoms bonded to a single oxygen atom. Two hydrogens and one oxygen. H2O. That's a compound. The example on the board is sodium chloride, NaCl. Sodium chloride is, I hope you recognize the name of that stuff. You would call it salt. I do want to pause for just a second and talk about that. Salt, like sugar, like alcohol, like steroids, those are all names of things that when I say the word of those things, you imagine one thing. You imagine a single thing. When I think salt, you think the stuff you put on your french fries. When I say sugar, you think the stuff that you put in your sweet tea. When I say alcohol, you think the stuff that makes you make bad decisions. Salt is not a thing. Salts are a class of things, and we'll talk about these class of things a little bit later on. There are lots of salts. Sugar is not a thing. Sugars are a class of things. I'm sure in your kitchen you probably have more than one kind of sugar. You might have some cane syrup. You might have some granulated sugar. You might have some powdered sugar. You might have some brown sugar. There are lots of different kinds of sugars. Alcohol. There are lots of different kinds of alcohols. There's probably more than one kind of alcohol in your house. Yeah, I got some beer and some wine, and somebody left like a little bit of Jimmy Beam, and then... No, that's not what I mean. What I mean is you've got the kind of alcohol that you drink, and then you've got another kind of alcohol, probably in the bathroom, right? It's called rubbing alcohol, and you know you're not supposed to drink that stuff. You can't drink that stuff because it will make you sick. Alcohol is not a thing. Alcohols are a class of things. So, yeah, don't drink rubbing alcohol. It will make you sick. Sodium chloride is a compound. And all of those things we just talked about, sugar, salts, alcohols, steroids, those are all compounds, which means they're made of lots of different atoms bonded together. We'll talk about bonding at the end of this chapter. Sodium chloride. If I take this element called sodium, which I'm not sure if you can see it, all the time when you watch these videos, please do make sure that you have downloaded the PowerPoints and that you have them next to you so that you can look at the pictures. It'll be a lot easier because I'm sure the pictures don't come through very well on the video. If you look at this picture, you can see this is sodium. Sodium is actually a metal. It's a very soft metal. It's a metal that can be cut with a knife. Chlorine at room temperature is a gas. Chlorine gas is poison. This is like what they gassed soldiers with in World War I, killing people with chlorine gas. All right? So, sodium is a metal, and the reason why this guy's wearing gloves to handle it is because as soon as sodium comes in contact with water, it will split the water apart, and it will release the hydrogen actually pretty violently, and it will get hot and will often start to burn. Because we're mostly water, we have water in our skin, it will burn your skin if you were to touch metallic sodium. So this stuff will burn you. This stuff will kill you. You put the two of them together, and this stuff tastes good on French fries and mashed potatoes. All right? Sodium chloride. What that illustrates is when two or more elements are bonded to each other, it really, really changes the properties of the two of them together. These two deadly things turn into something that we actually need because we need sodium in our bodies and we need a little bit of chlorine in our bodies. But they have to be bonded to each other to get them into us before, so they don't kill us. Otherwise, if they weren't bonded to each other and we try to take them separately, it'll kill us. There are three forms of matter. Look at the screen, look at the pictures. What form of matter is here on the pictures? The form of matter that we have on the pictures is water in all three of its states. The first state is solid water. We call it ice. The next one is liquid water. Liquid water is water. And the last one is gaseous water, which we call steam. If I want to convert the solid into the liquid, what do I do? I'll heat it up. Yes, you heat it up. But in science, we would say you add energy. If you want to turn the liquid into the gas, what do you do? The answer is you add more energy. What if I want to turn the liquid into a solid? Oh, you freeze it. Yes, you freeze it, but you say we remove energy. Because you can't add cold to something. Cold does not exist. Cold is simply the absence of heat. Just like dark doesn't exist. Dark is the absence of light. Dry doesn't exist. It is the absence of water. Can you add dry to something? Can you add dark to something? No. You can't add cold to something. You can remove heat, you can remove water, you can remove light, but you can't add the opposite. So to turn liquid water into solid water, you remove energy. To turn gaseous water into liquid water, you remove energy. And actually you do it this direction. To turn gaseous water into liquid water, you remove energy. To turn liquid water into solid water, you remove more energy.